Now in this video, we're going to go over integration, how to find the antiderivative of certain functions. Now, if you recall, according to the power rule, the derivative of x raised to the n power, that is a variable raised to a constant, is equal to n x raised to the n minus 1. Now, the power rule, when dealing with antiderivatives or integration, is like this. Instead of subtracting the exponent by 1, you need to add 1 to the exponent. And instead of multiplying, you're going to divide the result of what you see here. And plus, you need to add the constant of integration. And so that's basically the power rule for integration. Let's work on some examples. So let's say if we wish to find the derivative of x cubed. Using the power rule, we could see that our n value is 3. So it's 3x raised to the 3 minus 1, which is 2. So the derivative of x cubed is 3x squared. Now let's say if we wish to find the antiderivative of 3x squared. What we need to do in this case is add 1 to the exponent and then divide by that new exponent. 2 plus 1 is 3, and 3 divided by 3 is 1. And so this gives us our original answer, which is x cubed. But we need to add the constant of integration. If we were to take the derivative of x cubed plus the constant of integration, it will give us 3x squared plus 0. The derivative of any constant is 0. And so we don't know what this constant could be. It could be 5, it could be -8, it could be 0. But when dealing with an indefinite integral, you always need to add the constant of integration. Now let's find the antiderivative of x to the 4th. Go ahead and work on this example. So using the power rule, we need to add 1 to 4 and divide by that result. And let's add c. So 4 plus 1 is 5. So it's going to be x to the 5th power divided by 5 plus c. But you can also write your answer like this. You could say it's 1/5 x to the 5th plus c. Go ahead and try these two examples. Find the antiderivative of x squared and x to the 7th. So feel free to take a minute and try those two. So this one is going to be x to the 3rd over 3 plus c. You just add 1 to 2. And then 7 plus 1 is 8. So this is going to be x to the 8 over 8 plus c. And so that's a simple way in which you could find the antiderivative of a monomial. Now, what is the antiderivative of x? What's the answer? So this is x to the 1st power. So it's going to be x squared divided by 2. And that's it for that one. Now, what about this? What if we have a fraction? What is the indefinite integral of x over 4 dx? In this case, what you could do is rewrite it. Let's move the 4 to the front. And so this is the same as 1/4 antiderivative of x dx. And then use the power rule. So that's going to be 1/4 times x squared over 2 plus c. So 4 times 2 is 8. The final answer is going to be 1 over 8 x squared plus c. Now what about this one? Let's say if this is 8x to the 3rd power. What's the answer for this one? Well, let's move the 8 to the front. And then let's find the antiderivative of x cubed. So 3 plus 1 is 4, and then let's divide by that result. And now we could simplify it. So 8 divided by 4, that's going to be 2. And the answer is going to be 2x to the 4th power plus c. Now what about a constant? What is the antiderivative of 4? All you need to do in a situation like this is add a variable to it. So since we have dx, we're going to add the variable x. Let's say if we have the integration of 5 dy. The answer will be 5y plus c. Now let's go back to the first example. To show your work using the power rule, here's what you could do. 4 is the same as 4 times x to the 0 power, because anything raised to the 0 power is 1. So if we add 1 to 0 and then divide by 1, this will give us the same result, 4x. And so that's what you could do when dealing with a constant. So the antiderivative of -7, let's say dz, this would be -7 times z plus c. So based on what you see here, you need to introduce that variable in your answer. Now let's find the antiderivative of a binomial. Let's say 7x minus 6. Go ahead and try that. So what you need to do is integrate each component of this expression separately. So the antiderivative of 7x is going to be 7x to the second power over 2. And for a constant, we simply need to add an x variable to it. And then let's add the constant of integration. And so this is the answer. Here's another one. Find the antiderivative of 6x squared plus 4x minus 7. Go ahead and find the antiderivative of that particular trinomial. So let's add 1 to 2. 2 plus 1 is 3, and then divide by the exponent. And then let's add 1 to this exponent. So 1 plus 1 is 2, and then divide by 2. And the antiderivative of -7 is -7x. Now let's simplify it. So 6 divided by 3 is 2. And then 4 divided by 2, that's 2. And so this is going to be the answer for this problem. So as you can see, it's not really too difficult finding the antiderivative of a function. As you work out a few problems, it gets easier. But now let's move on to radical functions. What is the antiderivative of the square root of x? Go ahead and try that. Now the first thing you need to do is you need to rewrite the expression. This is x to the first power, and the index number is a 2 if it's not present. So this is the same as x to the 1/2 as a rational exponent. And now let's use the power rule. So let's add 1 to the exponent and then divide by that result. So 1/2 plus 1 is the same as 1/2 plus 2 divided by 2, because 2 divided by 2 is still 1, and 1 plus 2 is 3. So 1/2 plus 1 is 3 over 2. So now we have x raised to the 3 over 2 divided by 3 over 2. Now what I'm going to do is multiply the top and bottom by 2/3. And so here, the 2's will cancel, and the 3's will cancel. So 1 divided by 3/2, or 1 divided by 3 over 2, is the same as 2 over 3. All you need to do is flip the fraction. So the final answer for this problem is 2 over 3 x raised to the 3 over 2 plus c. Now you could leave your answer like this if you want to, or you can convert it back into its radical form. And so x to the 3/2 is the same as the square root of x cubed. Now you really don't need to write the 2. You can put it there if you want to, but it's the same. So you can also leave your answer like this if you prefer. Let's work on another example. Find the antiderivative of the cube root of x to the 4th. Go ahead and try that. So step 1 is that we need to rewrite it. This is x raised to the 4 over 3. The index number goes on the bottom, and the exponent goes on the numerator of the fraction whenever you want to convert it from its radical form into a rational exponent. So now, let's integrate the expression. So this is going to be x raised to the 4 over 3 plus 1 divided by 4 over 3 plus 1. Now we need to get common denominators, so I'm going to replace 1 with 3 divided by 3. And so now we can add the numerators of those two fractions. So 4 plus 3 is 7. And so what we have right now, let's not forget plus c, this is going to be x raised to the 7 over 3 divided by 7 over 3 plus c. Now x divided by 7 over 3 is the same as x times 3 over 7. If you wish to show your work, what you could do is multiply, like we did before, by the reciprocal of 7 over 3. And so these will cancel, and the 7s will cancel. And so the final answer is 3 over 7 x raised to the 7 over 3 plus c, or we can write it like this: 3 over 7 times the cube root of x to the 7 plus c. And that's it. Now for practice, let's try another one. Let's try the fourth root of x to the 7th power. So take a minute and work on that example. So just like before, we're going to rewrite it. So this is x raised to the 7 over 4. And now let's add 1. So this is going to be 7 over 4 plus 1 divided by 7 over 4 plus 1. Now 7 over 4 plus 1, we can replace the 1 with 4 over 4. So 7 plus 4 is 11. And so we get x to the 11 over 4 divided by 11 over 4 plus c. And so instead of dividing it by 11 over 4, we can multiply the x variable by the reciprocal, which is 4 over 11. So it's 4 over 11, x to the 11 over 4 plus c. And then we can rewrite it as 4 over 11 times the fourth root of x to the 11 plus c. And that's all you need to do for that example. Now let's talk about the integration of certain trigonometric expressions. And so if you have a notepad, you may want to write down some notes. Now, recall that the derivative of sine x is cosine x. So therefore, the antiderivative of cosine x dx has to be sine x plus c. Now, the derivative of cosine x, we know it's negative sine x plus c. So the antiderivative of negative sine x dx has to be positive cosine x plus c, which means that the antiderivative of positive sine x dx must be negative cosine x if we reverse the sign. And there's no point reversing the sign for the constant because c could be 5 or negative 5, it doesn't matter. Now, let's move on to the derivative of tangent x, which is secant squared. So the antiderivative of secant squared is tangent x plus c. And so these are formulas that you just have to know. If you don't know them, make sure you write them down. And as you do your homework, you're going to become familiar with those expressions. Now the next one, we know that the derivative of cotangent is negative cosecant squared. So the antiderivative of negative cosecant squared is cotangent. And the antiderivative of positive cosecant squared is going to be negative cotangent x. Next up, we have the derivative of secant x. And so that's going to be secant x tangent x. So the antiderivative of secant tangent, as you know by now, has to be, well, let's not forget dx. So this has to be secant x plus c. And the last one, the derivative of cosecant x, is negative cosecant x cotangent x. So the antiderivative of positive cosecant x cotangent x, changing the sign, has to be negative cosecant x plus c. And so make sure you know those common trigonometric expressions along with their derivatives and integrals. So let's say if we wish to find the antiderivative of 4 sine x minus 5 cosine x plus 3 secant squared x. Now the antiderivative of sine is negative cosine, and the antiderivative of cosine is positive sine, and the antiderivative of secant squared is tangent. And so the answer is going to be negative 4 cosine x minus 5 sine x plus 3 tangent x plus c. And that's it. So as you can see, it's important to know the integrals of common trig expressions so you can do questions like these. Now, let's talk about the difference between an indefinite integral and a definite integral. An indefinite integral looks like the expression on the left. On the right, I'm going to draw a definite integral. A definite integral has the lower limit of integration and the upper limit of integration. And so it has those values. The indefinite integral will give you an answer in terms of x. So you get an algebraic expression, whereas a definite integral will give you a number. Your final answer should be a specific number like 25, 36, or something. So let's go through both examples. So to find the indefinite integral of 6x squared, we need to use the power rule. And so the answer is going to be 2x cubed plus c. So anytime you're dealing with an indefinite integral, you're going to get an expression in terms of some variable plus the constant of integration. Now, when dealing with a definite integral, you don't need to worry about the constant of integration. It's going to disappear. Now, we still need to use the power rule on this expression. So that's not going to change. So we're going to get 2x cubed. Now, we need to evaluate it from 1 to 2. So the first thing you need to do is replace x with 2. And then you need to subtract it by replacing x with 1. 2 to the third power is 8, and 1 to the third power is just 1. So it's going to be 16 minus 2, which is 14. And so that's how you can evaluate a definite integral using the limits of integration. Now, let's say if we incorporated the constant c at this point. So once we integrated this expression and got 2x cubed, what's going to happen if we introduce the constant of integration? So when you plug in 2, you're going to get 2 times 2 to the third power plus c, and then minus 2 times 1 to the third plus c. So notice that c cancels. C minus c will disappear, and so your answer will still be 14. Thus, when dealing with definite integrals, it's not necessary to add the constant of integration. You could just ignore it. Go ahead and try this one. Let's say if we have 8x minus 3 dx, and we wish to evaluate it from, let's say, 2 to 3. Go ahead and find the value of that definite integral. So first, let's integrate the expression. This is going to be 8x squared over 2 minus 3x from 2 to 3. And then 8 divided by 2 is 4, so we can write that as 4x squared. Now the first thing we're going to do is plug in the top number 3. So let's replace x with 3. And now let's replace x with 2. 3 squared is 9. 9 times 4 is 36. 3 times 3 is 9. 2 squared is 4 times 4, that's 16. 3 times 2 is 6. 36 minus 9 is 27. 16 minus 6 is 10. And 27 minus 10 is 17. And so this is the answer. Now, I want to take a minute to let you know that for those of you who want to support my Patreon page, I'm going to post the second part of this video. So the video that you're currently watching is just the first half of the video. But if you want to have access to the second part of the video, feel free to check it out on my Patreon page. And you can also access other video content that I have there as well that you might find interesting. So feel free to take a look at that when you get a chance, and let's get back to the lesson. Now, just to give you some background info, the process by which we evaluate the definite integral comes from the fundamental theorem of calculus. One part of it says the integral from a to b of some function f of x dx, where this function is continuous on a closed interval from a to b, is equal to the evaluation of the antiderivative, which is capital F, at b minus the evaluation of the antiderivative f at a. And so basically that's what we did. We've integrated f of x to give us the antiderivative capital F, and then we plugged in the top number first, and then the bottom number later. And so the way we evaluate the definite integral, it comes from the fundamental theorem of calculus. Now, it's important to know that the integral of f of x dx, that is the indefinite integral, is equal to the antiderivative, which is represented by capital F, plus c. So make sure you understand this. Capital F is the antiderivative of lowercase f. And if you were to take the derivative of capital F, it will give you lowercase f. So the derivative of capital F of x is equal to lowercase f of x. Now let's talk about exponential functions. The derivative of an exponential function like e to the u is e to the u times u prime. Now what about the antiderivative of e to the u? Now if u is a linear function, let's say ax plus b, you could use this formula. It's e to the u divided by u prime. If it's a quadratic function, a cubic function, it's not going to work. So let me give you some examples. Let's say if we wish to find the antiderivative of e to the x. It's going to be e to the x divided by the derivative of x, which is 1, plus c. And so it's e to the x. Now let's say if we want to find the antiderivative of e to the 5x. It's going to be, well, let's write the formula if you wish to follow it. So remember, it only works if u is a linear function. So u is 5x, that means u prime is 5. So it's e to the u, that's e to the 5x, divided by 5 plus c. And so that's it. So let's say if we wish to find the integral of e to the negative 7x, and also let's say e to the 3x minus 5. For the first one, it's going to be e to the negative 7x divided by the derivative of negative 7x, which is negative 7, plus c. And for the next one, it's going to be e to the 3x minus 5 divided by the derivative of 3x minus 5, which is 3. And so that's a quick and simple way in which you can basically find the antiderivative of exponential functions if this is a linear function. Now let's work on a similar problem, but using a different technique to get the answer. So for this one, we know the antiderivative of e to the 8x. It's e to the 8x over 8 plus c. But let's use another method to get that answer. And the method that we're going to use is something called u substitution. We're going to make the u variable equal to 8x. And we're going to find the differential of u, which is du, and the derivative of 8x is 8 times the differential of x, or dx. So du is 8 dx. Next, we're going to solve for dx by dividing both sides by 8. So du over 8 is equal to dx. Now, let's replace 8x with the u variable, and let's replace dx with du divided by 8. Now, it's important to understand that the antiderivative of e to the x is e to the x plus c. And this is something that you need to commit to memory. So make sure you know that expression. So right now, we have e to the u, and then dx is du over 8. And we're going to move the 8 to the front. So it's 1 over 8 integral of e to the u du. And the antiderivative of e to the u is just e to the u, just as the antiderivative of e to the x is e to the x. So this is 1 over 8 e to the u plus c. Now, we need to replace the u variable with 8x. So the final answer is 1 over 8 e to the 8x plus c. And so that's how you could show your work using the technique known as u substitution. Now let's try another example. What is the antiderivative of 4x e raised to the x squared dx? Now for this, we need to use u substitution again. But this time, we're going to make u equal to x squared. Du is going to be the derivative of x squared, which is 2x times dx. And now let's get dx by itself. Let's divide both sides by 2x. And so this disappears. So dx is du divided by 2x. Just like we did before, let's replace x squared with the u variable, and let's replace dx with du over 2x. So this is going to be integral 4x e to the u times du over 2x. Now we can cancel these two. 4x divided by 2x is 2. And let's move the 2 to the front. So it's 2 integral e to the u du, which is equal to 2 e to the u plus c. Now the last thing we need to do is replace u with x squared. And so the final answer is going to be 2 e to the x squared plus c. And so u substitution is a common technique that you need to be familiar with when dealing with integration. Now, let's talk about how to find the antiderivative of irrational functions. So what is the antiderivative of 1 over x squared? How can we find the answer here? Now, what we need to do is we need to rewrite the expression. And the way we can do this is by moving the x variable to the top. And as you do that, the sign of the exponent changes from positive 2 to negative 2. And so at this point, we could use the power rule. So what we can do is add 1 to the exponent and then divide by that result. And let's not forget to add the constant of integration. So negative 2 plus 1 is negative 1. And at this point, after you integrate it, you can move the x variable back to the bottom, where the exponent will change from negative 1 to positive 1. And so our answer is negative 1 over x, or x to the first power. And so this is the antiderivative of 1 over x squared. It's negative 1 over x. Now let's try another example. Let's find the antiderivative of 1 over x cubed. So go ahead and work on that problem. So feel free to take a minute and try it. Step 1 is to rewrite the problem by moving the x variable to the top. Step 2 is to integrate. Let's add 1 to the exponent and then divide by that result. So negative 3 plus 1 is negative 2. So we have x to the negative 2 power divided by negative 2. So after you integrate it, then rewrite it and simplify. So let's move the x variable to the bottom. And so this becomes, we can leave a 1 on top. This negative side, we could transfer it to the top. The 2 has to stay on the bottom, but now we have an x squared on the bottom as well. So the answer is negative 1 over 2x squared plus c. Now what about this one? Let's integrate 8 over x to the 4 dx. So go ahead and try it. Now because we have a constant on the top, I recommend moving it to the front. At the same time, let's move the x variable to the top. So this is going to be 8 times the integral of x to the negative 4 dx. And now let's find the antiderivative. So let's use the power rule for integration. Negative 4 plus 1 is negative 3. Now what we need to do is take the x variable, move it to the bottom, and we could take the negative sign, move it to the top. So we're going to have negative 8 divided by 3x cubed plus c. And so that's it for this example. Now let's integrate this expression. 1 over 4x minus 3 squared dx. Go ahead and try that. Now, for this type of problem, I recommend using u substitution. Let's make u equal to 4x minus 3. So du is going to be the derivative of 4x minus 3, which is just 4, and then multiply that by dx. Now, let's solve for dx. So dx is going to be du divided by 4, if you divide both sides by 4 here. So we're going to replace this expression with the u variable, and we're going to replace dx with du divided by 4. So this is going to be the integral of 1 over u squared times du over 4. Now let's take the 4, move it to the front, and let's take the u variable, move it to the top. So this becomes 1 over 4 integration u to the negative 2 du. Now let's use the power rule. So let's add 1 to the exponent. So negative 2 plus 1, that's going to be negative 1, and then we need to divide by negative 2 plus 1, or negative 1. Now let's move the u variable to the bottom, and let's move the negative sign to the top. So this is going to be negative 1 over 4 times u plus c. Now the last thing we need to do is replace the u variable with 4x minus 3. So the final answer is going to be negative 1 over 4 times 4x minus 3 plus c. And so that's what we need to do in this problem. Here's another similar example. Find the antiderivative of 7 over 5x minus 3 to the 4th power. Go ahead and try that problem. So first, let's use u substitution. Let's make u equal to 5x minus 3. So du is going to be the derivative of 5x minus 3, which is 5, times dx. Now what I like to do is, I always like to solve for dx. It helps me to avoid mistakes. And so du over 5 is dx. Now let's replace 5x minus 3 with the u variable, and let's replace dx with du over 5. So this is going to be the integral of 7 over u to the 4 times du over 5. Now, let's take the 7 and the 5 and move it to the front. And let's take the u variable and move it to the top. So this is going to be 7 over 5 integral u to the negative 4 du. So now let's use the power rule. Negative 4 plus 1 is negative 3. And we need to divide it by negative 4 plus 1. Now let's move the u variable to the bottom, and let's move the negative sign to the top. So this is going to be negative 7. On the bottom we have 5 times 3, which is 15. And then u to the third power plus c. Now the last step is to replace the u variable with 5x minus 3. And let's see if I can fit it here. So it's going to be negative 7 over 15 times 5x minus 3 to the third power plus the constant of integration. And so this is the final answer. That's all we need to do in that example. Now, what is the antiderivative of 1 over x? Go ahead and try that problem. Now, if we try to approach this problem like the other problems, instinctively we may decide to move the x variable to the top. And this will give us x to the negative 1. If we use the power rule at this point, it's going to be negative 1 plus 1 divided by negative 1 plus 1 plus c. Negative 1 plus 1 is 0. X to the 0 is 1, but 1 divided by 0 is undefined. And so we're going to have some issues here. So there must be something else that we could do. You simply need to know that the antiderivative of 1 over x is ln x. Because if you recall, the derivative of ln u with respect to x is going to be u prime over u. And so the derivative of ln x is going to be, if u equals x, u prime is the derivative of x, which is 1. So it's 1 over x. So if the derivative of ln x is 1 over x, the antiderivative of 1 over x is ln x. So that's one of those formulas that you need to commit to memory. Try this problem. Find the antiderivative of 7 over x dx. Now this is very similar to the previous problem. We just have a number on top. Now let's move that constant to the front. So this becomes 7 integral 1 over x dx. Now we know the antiderivative of 1 over x. You just need to know that it's ln x. And so this is our answer, 7 ln x plus c. Now what about this one, 1 over x plus 5? What is the antiderivative of that? This is going to be ln x plus 5 plus c. Now sometimes, some textbooks, they may have an absolute value with the natural log symbol, because x plus 5 can sometimes be negative for certain x values. And so you might see an absolute value expression here. Now we can get the same answer using u substitution. So if we were to make u equal to x plus 5, du is going to be the derivative of x plus 5, which is 1, times dx. So let's replace x plus 5 with u and dx with du. And so this gives us ln u plus c. And then we need to replace u with x plus 5. And so we get ln x plus 5 plus c. And so you could show your work using both techniques.